So switching on the supply, we get the readings. We can see the star connected load glowing so beautifully, and also the corresponding readings in the meters are displayed. The ammeter is reading 0.5 amps. The voltmeter is reading 408 volts. The wattmeter 1 on the display is reading 90 watts. Multiplied with its wattmeter constant, we have to tabulate the reading in the tabulation column. Similarly is wattmeter 2, which is reading 90 watts, and multiply it with the wattmeter constant and then tabulate in the tabulation column. Let's tabulate the readings now. So after tabulating the readings of VL, IL, V1 including its wattmeter constant and V2 including its wattmeter constant, the value of W, which is the sum of W1 and W2, is calculated, and the value of P, which is the theoretical formula for calculating three-phase power, is given as root 3 VL IL cos phi. So we know the value of VL, we know the value of IL, we know the value of cos phi because this is a wattmeter of UPF type, so cos phi is always 1. So take the reading, calculate the values by substituting them in this formula, and you get 353.33, which is approximately rounded up to the nearest highest digit, 354. And W is nothing but the product of W1 and W2, which is 360 watts. So if you can see the theoretical, this is the theoretical value and this is the practical value. They both are almost close, more or less, considering that there are human eye errors while taking the readings in an analog meter. We are finalizing that the three-phase power for a star connected load is measured. So now let us do the next part of this experiment, which is finding out the three-phase power in the delta connected load. Considering let us compare the circuits of star connected and delta connected circuit. On the portion till here will remain the same for both of them. Let us compare it this way. So this part of the circuit is the same, this part of the circuit. Only in this region you will find the difference. In star connected load, all the similar points will meet at a point, whereas in delta connected load, the dissimilar points will meet at a junction. Alright. So let us now just connect the delta connection and then further connect it to the existing circuit connection. So till here we are retaining the experiment as it was in the previous section and just manipulating the connections in this part. So here you can see we have removed the connection of the star connected load, and now let us connect it in delta. From FR, see SR is connected to FR internally, isn't it? SR is connected to FR. From FR we have the line that comes to SB as shown in the circuit diagram. FR is connected to SB then. From SB, FB is connected internally. FB is further connected externally to SY. So let us do the connections. SR to FR is done internally. From FR to SB, SB to FB is connected internally. Then from FB we are connecting it to SY. So this is SY connected, and SY is connected to FY internally, and FY is further connected to SR. So this completes the delta connected connection for the given circuit. Now they are also connected with the rest of the circuit diagram, and let us switch on the circuit and see how the circuit behaves in this case. Now let us switch on the circuit for the delta connected 2 wattmeter method circuit and see how the circuit behaves. Now we see the lamps glowing much brighter than what it was in the previous condition, and we know the reason why it is happening because of the previous experiment. The readings of voltage and current and the power consumed is also being recorded in the meters. The current the ammeter is recording 1.2 amperes. The voltmeter is recording 408 volts. The wattmeter 1 is displaying 260, and this number you have to multiply it with the wattmeter constant 2, and wattmeter 2 is displaying 160. Again multiply it with the wattmeter constant 2 before you tabulate in your tabulation column. Now let us do the further calculations in the tabulation column. Let us switch off the circuit. Tabulating the readings of the experiment we just conducted. VL, IL, W and W2, W and P, we can notice that the values of P and W are almost close. So this indicates that we have completed measuring the three-phase power of both star and delta connected loads. And let us now understand what are the advantages of 2 wattmeter method over the other types of existing methods. This method is applicable for both balanced as well as unbalanced loads. Only 2 wattmeters are sufficient to measure the total three-phase power. We don't need an extra wattmeter to do the same job. So we are saving in device 2. Then total reactive volt amperes can be obtained using 2 wattmeter readings for balanced load. And hence, this is the experiment of measuring three-phase power using 2 wattmeter method. Thank you for watching. Hope you have understood completely.